Now in this problem, triangle PQR is an equilateral triangle, and you have been given that this point S is such on QR that QS is equal to 1/3 of QR. You have to prove that 9 times PS square is equal to 7 times PQ square. Now as triangle PQR is equilateral, so each angle will be of 60 degree. They have given you that information. If you want to use it, you can use it. Otherwise, we can apply Pythagoras theorem and get the required result. Okay. Now, another thing, they have given you this PT without any marking. I consider it as perpendicular. Now, why is it so? See, there's a property for an equilateral triangle that for an equilateral triangle, the altitudes, the medians, the perpendicular bisectors, angle bisectors are one and the same. Okay, so without any marking over here, we can consider PT as perpendicular to QR. We can consider PT as perpendicular bisector of QR. We can consider PT as the median also. We can consider PT as the angle bisector of this angle P. Okay, so this relationship we have written over here. As triangle PQR is equilateral, so all the three sides are equal. Also the altitude, the median, the perpendicular bisectors and the angle bisectors are one and the same. Therefore PT, not QT. Therefore PT is perpendicular to QR. This is PT, perpendicular to or perpendicular bisector of QR. Now as such, our claim requires PS square. So we will apply Pythagoras theorem first for triangle PST, this triangle. So in triangle PST, by applying Pythagoras theorem, you get PS square is equal to PT square plus ST square. Now you do not require this PT. To remove this PT, we will apply Pythagoras theorem for this triangle PQT. And for this triangle PQT, this PT square is nothing but PQ square minus QT square. Are you getting this? PT square will be what? It will be PQ square minus QT square. So we have substituted over here for PT square, PS square minus QT square, this ST as it is. And we have given the reason by Pythagoras theorem for right triangle PQT. Okay. Now, as such, we need for this triangle, now we got PS square already over here. Okay, here we have to write in place of PS, we have to write PQ square minus QT square. Okay, so PS square is equal to PQ square. Now this QT, what is this QT? It is half of QR, because PT is the perpendicular bisector of QR. If it is the bisector of QR, this QT will be how much? This QT will be half of QR. Okay. PT is what? Perpendicular bisector of QR, or PT is the median. If PT is the median, then T is the midpoint. And if T is the midpoint, then QT is half of QR. So here we write minus, in place of QT, half QR whole square. Okay. What about ST? ST we can write it in terms of this ST. This ST, it is QT minus QS. If you, from QT, if you remove QS, you get ST. Have a look here. This is your QT. From this QT, if you remove QS, what is left is ST. So in place of ST square, we are going to write it as QT minus QS whole square. Okay. So now PS square is equal to PQ square minus 1/4 times QR square. What is this QT? Okay. QT is nothing but half of QR, because PT is the perpendicular bisector. Then QS is what? This QS is 1/3 of QR. So instead of QS, we'll write 1/3 times QR whole square. The reason we can write here, we can put, since T is the midpoint of QR. Fine. So PS square is equal to PQ square minus 1/4 times QR square plus. Now if we denominators are unlike, so we will cross multiply. Thrice QR minus twice QR upon 2 3s is 6 whole square. So here you get PS square is equal to PQ square minus 1/4 times QR square, and 3 minus 2 is 1. 1/6 times QR whole square. So this becomes PS square is equal to PQ square minus 1/4 times QR square and 1/36. 6 square is 36 QR square. Fine. Now what to do? If you look at the claim again, the claim says 9 times PS square is 7 times PQ square. So let us change now. We will multiply this equation by, complete equation by 9. So therefore 9 times PS square is 9 times PQ square minus 9 into 1/4 times, instead of QR, I'll make it PQ. Why? Because PQ is equal to QR. Fine. So we will write the reason over here, plus 9 times 1/36 PQ square. Reason you'll write from 1. Now here you will get 9 times PS square is 9 times PQ square minus 9/4 times PQ square, and 9 ones are 9 fours are. Okay, so 1/4 times PQ square. So as such, here the denominators are same. We can simplify the numerators. PS square is equal to 9 times PQ square. Denominators are same. Minus 9 plus 1 is minus 8/4 times PQ square. Are you getting that? This is minus 9 plus 1. Denominators are same. So minus 9 plus 1 is minus 8/4 times PQ square. 4 ones are 4 twos are. So 9 times PS square is 9 times PQ square minus twice PQ square, and that gives you the result as 7 times PQ square. Have a look at the result. What you have been asked has been proved over here. See, 9 times PS square is 7 times PQ square. This is what we had to prove, and we got the result. 9 times PS square is equal to 7 times PQ square. Okay, so here you can add one more reason, multiplying by 9. Multiplying the equation by 9. So you multiplied the complete equation by 9. Okay, I hope you understood this proof. Kindly hit the like button, subscribe to my channel please.